And we should be streaming for World Quant office hours. I believe I am going through. I believe I am transmitting. All right, guys, welcome to World Quant office hours week and 6. We should be streaming for World Quant office hours. If I do remember it correctly, we are in week 6, Wednesday, November 4th, the year 2020. Hope everyone is doing fine and well wherever you guys are located. Right now I look outside my window and it appears to be a sunny day, so perhaps I should get some sunlight. It's 36 degrees Fahrenheit, so maybe if I do my math correctly, that's 4, that's 20, about 2 degrees Celsius, here in Boston. In fact, let me just do that conversion. 36 Fahrenheit to Celsius. Yeah, 2.2. Yeah, I wasn't too far off in my math there. 2 degrees Celsius. I see that Shakiba is here. Hello, Shakiba. Welcome to World Quant Office Hours. Hope you are doing fine today. I see Tom Byrne is here. Hopefully maybe it's not as rainy so much right now where you are in the UK, near Manchester, if I recall. Joseph is here. Lyndon Smith, thank you for letting me know. You can hear me loud and clearly. Hope everyone is doing fine today. Let me throw up the agenda. Oh, now I can draw arrows here. I must have updated this. Okay. Now you can switch what you can draw. I'll throw the agenda there. And we'll continue our progress on the DW mini project. But do let me know anything else to throw up on the board. I see that Akina is here. Ragarash. All right, apparently it's dry. I see Sumyadip. Hello, Sumyadip. Welcome to World Quant Office Hours. Okay. All right, so someone said they had a question for you before you start. Go for it. The floor is open. Let me know. What is your question? To sort. All right, so your question is to sort. So do let me know. Okay, I see you. I'm looking at the chat right here. I had a question, can we use dictionary values to sort? And I see Emmanuel is also here and Andre is here. Hello, welcome to Office Hours. All right, can we use dictionary values to sort? And is this in the context of, okay, I see a little more context here, to sort the values of a dictionary. Well, the thing about dictionaries is that there really isn't an order to dictionaries. Yes, technically there's an order to dictionaries, but you typically aren't going to want to do any sorting on your dictionaries. You perhaps want to sort an iterable that results from your dictionary. So for example, let's go ahead and sketch that out. So let's go into Office Hours, open up a new Python 3 notebook. And do you have Sumyadip, do you have a specific example you have in mind so I can further narrow down your question? Let me just get this ready. Office Hours. November 4, 2020. So do you have, so do let me know. I think it, maybe perhaps you have, maybe you have something like this, where you have different keys. And here I'm just picking letters from the alphabet. Maybe something like that is the longest string value. So you're right, the context is the longest string value. So are you looking to sort the keys, or are you looking to sort, you're looking to sort the values? If I can say D here. Dictionary values to sort the values of a dictionary. So you could say, if you do, you could say sorted D values. and this will return to a list of the sorted values of the dictionary. And this does it from descending order, so you can always say reverse equals true if you want to flip that. 4, 3, 2, 1. So maybe you have these, maybe your dictionary is not like that form. So maybe you have it like Don and Ralph and Steve and Susie or something like that. If you do values and sort by alphabetical order, and since I said reverse equals true, there you go. So that does it by alphabetical order. So you could do something like that. You can pass dot values. This returns an iterable of the values of the dictionary, pass it to the sorted function, and returns a list of the sorted values of the dictionary. And if they're names, then it will sort them by alphabetical order by default, but you can reverse that through the reverse keyword argument. So let me know if that is answering your question. We can further talk about it. I see something else going on in the chat here. All right, I guess that answered your question. So yeah, let me know if that did, and I believe that is the case. So look at else here going on in the chat here. Can we swap between R and Python in Jupyter Notebook? Not good with R, but USBEA data has a library for R, but a more unstable one for Python. I'm not sure if there's a way to interchange the kernel for Jupyter Notebook. So in Jupyter Notebook, we could, notice how right here, this here tells us the kernel we are using. In other words, what is the interpreter we're using for this session? Because indeed, you can use other languages with Jupyter Notebook. It's not a Python specific tool. It works with R and perhaps with Julia and a couple of other languages. So kernel, and you can actually change the kernel here, but only have Python 3 kernel available. But you can have other kernels available. I'm not sure if it's possible to have certain cells use a different kernel than the other. So that might lead to a little bit wonkiness. However, what you could do is you can always have it set up where you have your process in R, and then run this process, and maybe have this process dump some file, maybe some file to disk. And then you have a Python process. That's my version of a snake with its tongue sticking out, although I don't think, yeah. Although Pythons, I don't think they do that. Maybe they do. I don't know. Then you have a Python process that can read this file and then do some further analysis on it. You could do something like that. A two-step process. I think that's the way you'd have to do that. Okay, let's see. You're right. Let's say the context of the longest string value. Sort the values of, let's say, some names. We could pass the length method too. So we say pass the length method too. You could give it a key, which is a further criteria to further sort these values. So you can say lambda x length of x, and now we're going to sort by length of the name. We can also sort, we can sort by the length of the name now, if we give it a key. Assume Adept is saying you can have different cells, different languages in RStudio. So it looks like that is a capability you can have in RStudio. I never worked with RStudio before, so thank you for letting us know that is a possibility within RStudio. So maybe Ragaraj, maybe you want to use RStudio for that. It looks like that has that capability you're looking for. Our production ML code written in Jupyter Notebook, I get a lot of flack for not using VS Code or similar. All right, so for I think there's been a push. I think this reminds me of an article I read. I think I believe Netflix has productionized Jupyter Notebooks. And I think they might have released Netflix Jupyter Notebooks in production. And I can innovation in Jupyter Notebook. So I think this, how is Netflix using Jupyter Notebooks in production? So you can take a look at this article. It is possible. I can understand why you might get some flack because, well, I think a lot of it is sometimes, we've been doing it this way, so this is the way it's done, right? In full disclosure, I'm not a big fan of notebooks, Jupyter Notebook, which is ironic because most of the teaching I do is through Jupyter Notebook. And the problem I have with Jupyter Notebook is that it's hard to keep track of state. It's very hard to keep track of state, which runs into trouble. In fact, yesterday in office hours, I didn't get the right solution. And I think the problem was because I was doing a lot of other cells to illustrate certain principles. And then when it came to run all the cells, I was losing track of state. However, that just means you might have to clean up your notebook and make sure you run the cells in order. And maybe I'm just more of an older person and I prefer working with a text editor and Python files. So I get the point, but sometimes we have to maybe be a little more open, and maybe if these are great tools, we can productionalize them. So take a look at that article. Maybe talk to your colleagues saying, hey, Netflix is doing something similar, and Netflix is a big successful company. So if they're doing it, why can't we do it, right? So hopefully that gets you helps you out in your task there. All right, let's go ahead and let me know any additional questions in the chat. I'm going to transition into the DW Mini project. And yesterday we worked on Q5. We're trying to find the greatest prescription growth. And we did our process, and that worked out. We got the correct answer. But I'm going to clean things up. I'm going to kind of clean things up. And then the whole motivation here is that maybe at some point we are going to package this code into a set of Python files that we can run on a given script and return some sort of CSV file that flags those practices that we should further investigate. So in that effort of cleaning things up, let's go ahead and clean up Q5. A couple of things I want to show you is this idea of method chaining. So I can say scripts 16, and I say pd read CSV, the DW data 2016 scripts. And then I can say, so I can put a little comment here that says read the data, run that cell, and then I have another cell here that says calculate the growth rate. And I say PCT growth is equal to, and I can just copy and paste what I had before. Paste that right there, and I'm going to change the name to growth rate. And then what I can do is I'm going to say results are equal to, the first thing I do is I take that series and I convert it to a data frame. So I call it the toFrame method. And the next thing I do is I want to add the raw counts as a column. And before the way I did that was I go here, right? I had this step where I created the series and then I assigned it to the data frame. So it was a two-step process. I can do that all in one step by using the assign method. So in other words, I can say assign, and I can give the name of the column and what should be the values of that column. So it's going to be scripts 16 BNF name value counts. So in here I am using method chaining. The fact that this here returns a new data frame in which I proceed to invoke a method which returns a new data frame. So I'm able to chain these operations together. So I assign a new column. And the next thing I do is I gotta filter out results in which the raw count is less than 50. So I say query. So query is a great way, a very convenient way to filter out records. So I only want those in which raw count is greater than 50. And that returns a new data frame. And that I notice I have some missing values. I just want to drop NA. Drop those missing values. That returns a new data frame. And the next thing I did is I said, let's sort by values. Sort values by the growth rate. And via ascending equals false. And then I said, well, let's reset the index. And then finally, let's rename some of those columns. I'm going to rename the index. I'm going to rename it to BNF name. And that is a column. So I say access equal to 1. And I'm going to be a little bit picky here, and I'm going to stick with single quotes because I use single quotes throughout. It's probably best not to mix and match. Be consistent. So now we can take this here and we can read what it says. I think this leads to a little more readable code. Of course, it may not be so easy to come up with this solution right away, but after we come up with it, we can take what we did and package it nicely. So what we do is we create the series, we rename the series, we convert it to a data frame, we assign a new column based upon this result, column called raw count, we query it, we filter out records, we drop missing values, we sort the values by growth rate, we reset the index, and rename that column called index to BNF name. And then now we can go ahead and use PD concat to take the top 50 and the bottom 50. And let's do results head. And there we go. And there is our final result there. So making use of method change. So let me know if there are any questions before I move on to Q6. All right, I'm going to go and move on to Q6. All right, so for this question, we want to we want to see if practices are going to prescribe. We're going to look for practices that are prescribing rather rare prescriptions. What those drugs are, and how much more are they prescribing them. That's what we're ultimately trying to come up with. So the whole point here is maybe there is a generic that's available, and maybe they are not prescribing that generic. Maybe they really should, because it will save us on costs. So maybe we want to flag those places, those drugs that are being overly prescribed, which are rather expensive. And we can tell those practices to say, hey, keep in mind there is a generic available. It will save us a ton of money if you switch to that generic. Help us out here. So that's sort of the objective of what's going on for this question. Okay, so we got to be able to find, if we take a look at this, we got to be able to find those prescriptions that are rare. We want to find those prescriptions that are rare. And the way we're going to go about finding whether these prescriptions are rare or not is we are going to assume that all the prescriptions are sampled from a uniform distribution. So here is some sort of probability density, and here is our prescriptions laid out. Here are the different types of prescriptions. And we're going to assume they come from a uniform distribution. In other words, of course, this doesn't work in practice, but imagine you go to the doctor's office and the doctor says, okay, I'm going to prescribe you a medicine. And then from the n number of prescriptions that I can give you, I'm going to randomly give you one of them with a uniform distribution. So every prescription is just as likely to be prescribed. Of course, that doesn't happen in practice. You don't want your doctor to prescribe you whatever they pull out of a hat. But the reason we're going to do this is because we're going to first calculate what is this uniform probability. What is this uniform probability? And then we're going to compare what is the frequency of prescriptions for a given drug, and we're going to compare those two probabilities together. So in other words, let's think about a deck of cards. I know there's different styles of deck of cards. I know in the U.S. the popular style is 52 cards in a deck. I know, I believe in Mexico they use a slightly different system where there is only, I think there's only 40 cards in a deck. Because after 7, then you jump to the guy not on the horse, the guy on the horse, the king, and then the ace. So just put a little context there. All right, so let's assume you have a deck of cards, 52 cards in a deck. If we were to sample a random card from this deck using a uniform probability, so we have it well shuffled, and we're going to pull out a card. The probability of pulling out the ace of spades, which is one particular card, the ace of spades, well, that's 1 over 52. So the probability to sample the ace of spades is 1 out of 52, and the probability to sample any card in this deck, it comes from a uniform distribution. In other words, the probability to sample the ace of spades and the queen of hearts have the same probability. All the cards share the same probability. That's from a uniform distribution. And the way to calculate this probability that we will sample one of the cards is 1 over the number of cards. So using this idea, the uniform probability to sample a prescription is 1 over the number of prescriptions. So we say P uniform is equal to 1 over the number of types of prescriptions. Types of prescriptions. So we're going to first calculate this probability. And then we actually calculate the frequency of prescribing our predictions. So we actually calculate the p-value. Sorry, that sounded weird because p-value means something in statistics. We will calculate this probability. So probably for a given prescription I will be the number of I over total prescriptions. For example, if Tylenol is prescribed 100 times out of 1,000 prescriptions, its probability value will be 0.1. Just a ratio of the number of prescriptions of that drug over the total number of prescriptions. So we're calculating the actual frequency for each prescription. And then we're going to compare. We are going to say a drug is rare if its probability of being prescribed is less than 0.1 times the uniform probability. So our first task for this question is to flag which of our prescriptions are rare. And prescriptions that are rare are ones in which its probability of being sampled is less than 0.1 times the uniform probability. So let's work on that right now, that first chunk. Any questions about this step, what we're going to undertake now? Do let me know if any questions do come up. I'm going to go ahead and go ahead and working on this. So I will write out my plan of attack right here. And that is find rare prescriptions. First step is find the uniform probability. The next one is find frequencies for each drug. And then flag BNF codes that are deemed rare. Okay. So we want to figure out the uniform probability, which we call P. And as we said before, that is 1 over the number of types of BNF codes. Someone says, why not use a power transform fit to a Gaussian to take the 5 or 10% tail? Why not use a power transform fit to fit it to a Gaussian and take the 5 or 10% tail? Yeah, I guess we could have done something like that. But I guess we decided to take a little, maybe perhaps a simpler approach, which is flag those that are rare via, yeah, because we have the, well, let me think about that. Yeah, we could have done some sort of transformation, put it into a Gaussian, and then taken the tails, right? Some sort of threshold of the tails, 5%, 2%, 3%, 10%, whatever. Yeah, I guess we could have done something like that. Now I'm kind of curious to see how different our results would be if we did that. Here we'll just choose a simpler case. I'm kind of curious to see how the frequencies stack up. I'm kind of curious to see how they look like. But yeah, you think of there's some judgment call here. All right. And we know that in pandas, if I want to find the number of unique values, I could say scripts and say BNF code unique. This returns me all the unique values of a given column. I could take the length of that, would be the number of unique values, or more succinctly, I can just say scripts BNF code and unique. Same result. So every time you find yourself saying, hey, I want to find the number of unique values, there's a method for that, n unique. So we'll do that right there. So we'll say 1 divided by scripts BNF code and unique. And now we got to figure out the prescription rate. And the prescription rate, the frequencies, would be the number of prescriptions of that kind divided by number of prescriptions. So what's a good way I can figure out the number of times a given value appears in a column? How can I go about doing that? It's a nice little friendly method I've been using throughout these office hours. I want to find the number of each BNF code. How should I go about easily doing that? Yeah, value count, right? Values count. Yeah, exactly. So I can say scripts BNF code value counts. And that will give me a series where the indices are the BNF codes, a number of times they appear in that column. So if I want the rate, I divide that by how many prescriptions I have, by the length of prescriptions. Exactly, Raj, I would use values count. Value counts. I always forget how it's spelled. It's value counts. I always want to say values count, but it's value counts. And now we're good to go. And now we identify the actual frequency. And we can figure out those that are rare. Those that are rare are those in which their actual frequency, their rate, is less than the uniform probability. And this right here is a Boolean series, and we can create a series in our scripts data set equal to rare code. So now we're going to have a column of our scripts data frame that's going to tell us whether that prescription is rare or not. Very similar how we did before, where we had a column signifying, flagging whether a prescription is an opioid or not. This right here flags it whether it's a rare prescription or not. Let's run that there. I get a name error because, well, it's called rates and not rate. Right? Name errors, oftentimes misspellings, typos, what the not. Let's go ahead and examine scripts. It's always nice to take a look at what we've got. And it looks like we got a lot of NANs. So let's see if I have. I'm going to do drop NA. I'm going to do head. And it looks like I have nothing but missing values. I must have messed up something here. I think I know why. Anyone want to guess why, what I did wrong here? Why I have, if I do head, I have nothing but NANs missing values? Look at my rare codes. My indices are the BNF codes. And the indices of scripts are something else. Right? So I cannot. So in order for me to add this column, well, I got to make sure that scripts have the same index. I can say scripts set index. Set index to be BNF code. So now my prescription data set has the indices as the BNF code. So now I can easily add this column to my data frame. So remember that when we add columns to a data frame, make sure they are using the same set of indices. And that's why it's very important that we always take a look at our data frame as a result of the operations, just to make sure everything works out. And that's how I figured out something went wrong. So I look at head, and yep, now I have true, true, false, false, true. So now I have flagged whether those BNF codes are rare or not. All right, so that solved the first part. Do let me know if there are any questions before I talk about what to do next. We flagged whether drugs are rare or not. In fact, I'm kind of curious to see how many of those drugs are rare, so I can say print, let's do an F string, number of rare prescriptions, say scripts, rare. Since that's a Boolean, I can sum that up. Go ahead and do that there. Looks like quite a few number of rare prescriptions we got. And let's take a look at the frequency. If I set, what was it called, rates. Those are my rates there. Say bin 40. Yes, a very very skewed distribution of the prescription rates. I'm going to do np log. I take the log. I know I'm doing it wrong there. Log of, let's see, I can say rates, and then I can say plot bins 40, attribute error. It's called hist, not plot, hist. So I can take the natural log and I get something that resembles somewhat Gaussian, a little weird peculiarities there. But I could have maybe chosen some sort of transformation. I think Ragaraj was suggesting this, so it would be an alternative way. Use some sort of power transformation. Use some sort of transformation on our rates to get a Gaussian distribution. Because if we do the transformation to get a Gaussian distribution, we know that, if I remember my math correctly, that about 5%, about the tail, I think 90%, if I do my math right, 90% of the observations lie between -2 to 2 z-score. So I could have done that and figure out some sort of power transformation to get a Gaussian and flag those rare prescriptions. But we chose the method we chose. Right? I guess that's obvious. We chose the method we chose, right? It's in the name. It's in the phrase. All right. So it looks like there's a prescription rate. All right. So let's go ahead and let me know any questions people have before we transition to the next step. Okay, so now that we flagged those rare prescriptions, what we're going to do now, if we read this phrase here, for each practice, we want to calculate the proportion of costs that originate from prescriptions of rare treatments. So in other words, we're going to use the actual cost for this field. So we want to sum up what is the proportion of costs that originate from prescriptions that are rare. But it says, notice it says now for each practice. So now for each practice, calculate the prescriptions, the actual costs that originate from, for each practice, calculate the proportion of costs that originate from prescriptions that are from rare treatments. So in general, what is our strategy here? I'm not asking for Pandas code, but what's our general strategy right now? What strategy we should take? What broad stroke should we take to calculate the proportion of costs that originate from prescriptions of rare treatments for each practice? what are the general strokes we're going to take here? So since we are saying now for each practice, that should signal to you that I need to perhaps do a group by. So I should group by the practice and then do an aggregation to calculate the sum of actual costs, but only for those rare BNFs. In other words, we group by practice. We should filter, or you can view it, or first, you can view it, probably perhaps the first thing you do is filter. So let's perhaps filter out, filter to only include rare prescriptions. And let's group by practice. Let's group by the practice. And then we will aggregate to calculate the sum of actual cost. So that's our general broad approach attack here. The way we broke it down is the signifying was for each practice, got to do a group by. And we already have in our prescriptions data frame whether it's rare or not. And we got to merge in practice, right? I think we don't have the, let's see, our scripts. Our scripts actually have the practice, so there's no need to merge in the practice data frame, because the practice data frame has more information about the practice. We can just, but we already know what practice prescribed the prescription. So if we wanted to bring in the practice name, then we would do a merge. Maybe we'd have to do a merge later on, but not right now. So let's go ahead and try that out. So I say scripts, and I say query. Query is a great way to filter things out. So what I want is rare equal to true. Include those records where rare is equal to true. And then I can say group by the practice, and then I can go ahead and do the aggregation. I want to calculate index actual cost and compute sum. I'm going to call this rare cost total. And I also want to figure out the total cost. So regardless whether it's rare or not. So for every practice, I also want to figure out the total of actual cost. So I'll call that all cost total scripts. And there's no need to query here since I want to do this for all the prescriptions. So I group by practice and actual cost, compute the sum. And then I can go ahead and calculate the rare cost proportion. So let's go ahead and before I do that, let's go ahead and examine what we've got here. So I'll run those two cells. So you got rare cost total. So practice and how much their actual cost came from rare prescriptions. And I have all cost total. The cost from all the prescriptions for each practice. So now I can just do a ratio. I can say rare cost proportion is rare cost total over all cost total. So this will here tell me the proportion of for each practice what fraction of your actual cost was devoted to rare prescriptions. And I'll go ahead and print out rare cost prop. And there we go. So we have some practices. Looks like this one here. About 77% of the actual cost that incurred for prescriptions came from rare prescriptions. Right. This one here, ooh, look at this practice. Almost all of their prescriptions they gave out were for rare prescriptions. So maybe there's something weird going on in that situation. Maybe we should flag it and see what's going on, do an internal audit, make sure everything is good to go in that practice. Now let's go ahead and see and examine if there's any missing values. Let's just make sure there's any missing values. So I'm going to say the isNull method. I'm going to calculate sum. So isNull returns a Boolean whether it is a missing value or not. Sum was going to sum them all up. It looks like there is only one that has a rare, that has a missing value. So it looks like there is probably one practice out there in which maybe none of their drugs came from rare prescriptions. In fact, let's investigate that. I can say rare cost total, and I can say index, and I'll use set. So here is a set of all the indices of rare cost. And let's subtract that with all cost total index. So if I subtract two sets together, basically what I'm going to get is I'm going to get a set that tells me the members that are present in this set, but not in this one. And it looks like there is one practice. Let's examine that further. So I can say scripts, and I can say query, and practice equal. Copy that right there. So it looks like there was one practice that gave out just one prescription in which it was not rare. So we have a missing value. And the reason we have a missing value is because keep in mind that every time you perform operations on series, on two or more series, and there's an index present in one and not the other, to fill in that missing value, it does an NaN. So remember, when you do these operations in series, you might get missing values. And what that means is there was something present in one and the other wasn't. And we examine this further, and sure enough, that is the case. So here, what do you think might be the appropriate value we fill for those NaNs? Sometimes we got to fill in, we got to ask ourselves how we're going to treat those NaNs. Should we remove them? Or is there a logical value we should replace it with? So in this question here, what do you think is the logical value we should replace it with? Yeah, I agree with Raghuvaj, 0, right? Because clearly it's a missing value because they didn't have any rare prescriptions, so let's fill it in with 0. All right, looks like everyone is agreeing with me there, and I'll take a smiley face as also meaning 0. Andre, I agree with you as well. Let's go and fill in with a 0. So with that said, so that's why it's very important. That's why Jupyter Notebook is sort of a great environment to experiment with these things. Then maybe once we've honed down with our strategy, we can package it all together, which is what we're kind of building up to after we wrap up this mini project. So I'll call the fill NA. Sorry about that. I always have to cough to my sleeve, right? Cough to your sleeve. All right, fill NA, set that as 0. And now there is no null values. We fixed that there. And now we are good to go with the next step of this mini project. So now we figured out the fraction of prescriptions that came from the fraction of cost for each practice that came from rare prescriptions. And now we're going to calculate the z-score for that. And for that z-score, we're going to go ahead and we're going to say this rare cost proportion minus the global actual cost for rare prescriptions. So in other words, the rare cost proportion for each practice subtract by the global or the population value of the actual cost of rare prescriptions. And then we're going to divide. We'll first do that, and then we divide by the standard error. So we'll do this in two parts like we did before. Calculate the numerator, calculate the denominator. And in this case, our standard error will be the standard deviation of our relative rare cost proportion. Same procedure we did before. We'll calculate the z-score, and then from there we will figure out which of those practices that had the highest z-score. Maybe those are the ones we need to further investigate, make sure nothing fishy is going on. Alright, so that is our plan of attack. So let's go ahead and work that through. And I already calculated the rare cost proportion, so I can just comment that line out. So the relative one will be the rare cost proportion, subtract by the average rare cost proportion for the entire population, for the entire data set. So you say scripts query rare equal true, the actual cost, compute sum. So this is the actual cost of all the rare prescriptions for all the practices divided by scripts actual cost sum. So here is the total actual cost across all the practices. This one's for the rare one, so this will be the rate, the population rate. So now we have the relative values. We have our numerator. And we can take that rare cost proportion and calculate the standard deviation. And then we can calculate our z-scores, relative rare cost proportion, divided by our standard errors. And let's take a look at what we've got there. Rare scores. That should be a series. Alright, that seems to be fine. Nothing too crazy. You can do a histogram. Not the best, but let's bump the number of bins. Yeah, somewhat, not quite Gaussian. It is centrally distributed around 0. A weird bump around here. Kind of curious to see what is happening there. And some very large extreme values. So not quite Gaussian. But you can think of what we can do here is we can go ahead and flag those prescriptions, those practices that are beyond a certain z-score. So we can use a distribution to guide us what should be that cutoff. Alright, so now we're ready to format our answer for the grader. And we want 3 pieces of information. We want the practice code, the practice name, and the z-score. Looks like we give a sample answer at about 16. Let's take a look at whether we have that in our results so we know if we're on the right track or not. And what practice was it? It was for this one there. It's about 2.8. Ah. So maybe well, we'll see. We'll continue on this track. Let's see what happens. Okay. So we got our rare, what do we call it? Rare scores, I believe, is what we called it. Yep, and that's a series. So we got to bring in the practice information. And that was in, remember we had something called unique practices. This here had, as a code, the practice code. So now we can easily add to this data frame the rare scores. So say rare scores equal to rare scores. And since they already have the same indices, it made it very easy to add that column. We'll call head just to examine. Make sure everything seems to be fine there. And that appears to be the case. And now I can go ahead and say unique practices. And I want the top 100 z-score. So I should sort it by z-score. I can say sort values, rare scores, ascending equals true. And then I can say lock, give me all rows, but only give me the name. I'll probably reset the index. Reset the index since my code is my index. So then I reset and say give me the code, give me the name, and give me the rare scores. And then I say head 100. And ascending false, right? I don't know why I said true there. All right. Something a little fishy going on. Looks like I have a lot of the same rare scores. So I probably won't get the right answer from the grader. Probably have something messed up. But I think we have everything ready to at least submit to the grader. So I'll call this rare scripts. I'll pass that to the grader. I don't think I'll get the correct answer. I only have one match. I probably did some sort of mistake. Let's see if I can figure that out. Let's diagnose it. We notice one of the things, if we look at our results of rare scripts, these are kind of low. These are kind of low, given at least one of these samples. And a lot of them have the same value, which is kind of peculiar. So maybe I should examine my rare cost proportion. I did a histogram and that appears to be okay looking. So maybe there's something wrong in the way I calculate the z-score. Once again, maybe something wrong with the z-score. So rare cost proportions, subtract script query the rare actual cost sum, script actual cost sum. All right, so we have my rare relative rare cost, then my standard error, and then the z-score. So maybe something wrong in the way I'm calculating flagging rare prescriptions. Maybe something wrong here. Rare cost total. Query for rare, group by practice, actual cost sum. Then the all cost total, group by practice, actual cost sum. Hit the ratio here, fill in those missing values. So that appears to be also correct. Maybe something wrong in the way I flagged my prescription. So found the number unique. And then did values count, length of scripts, rare codes, rates. This is where I messed up. I know where I messed up. The criteria for a rare prescription is in which its rate is less than 0.10 times the uniform probability. That's my mistake right there. And now I get a key error, so there's no BNF code. I probably have messed up with state, so let me just rerun those cells. I think that is my mistake. Yes, got something that's more reasonable. Going through, and I still get the, well, now I get the wrong answer because I ran this cell, which gave me the default answer. And I get an error because I ran made too many greater submissions in my efforts to get a value of 1. But I believe that fixes my problem. With that said, we are over in time, so I have to head out. Let's see, my impatience. It should get a value of 1. But we'll have to pick this up tomorrow. Let me know if there's any questions. With that said, guys.